Dun 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 dun.
In our opinion, one of the more interesting topics that we have discussed over the course of this term is the relative scale of the solar system and its planets. However, the visual representations of our solar system appear to be somewhat abstract and difficult to comprehend. With this being the case, we decided to represent the solar system in such a way that would be easy to understand for everybody and also give people a better idea of how our solar system really works. So, in order to accomplish this, we decided to represent our entire solar system on something that most people would be familiar with, a football field. Starting with the Sun and ending with Neptune, our goal was to take the entire scale of the solar system and shrink it down to 100 yards. Here's how it went. To make things easy, we decided to put the Sun on the goal line. Everything else was placed in relation to that. We begin with the farthest known planet from the Sun in our solar system, Neptune. Neptune is approximately 2.793 billion miles away, but for sake of simplicity, we made it 100 yards. Due to its extreme distance from the Sun, Neptune is considered the coldest planet in our solar system, with temperatures ranging from approximately negative 300 to negative 360 degrees Fahrenheit. Due to being primarily made up of water, ice, and different types of gases, Neptune has less than half of the density that Earth does. Compared to the relative size of the Earth, Neptune is about 3.9 times larger. However, with regards to our representation of the Sun, this would make Neptune the size of a bean. After Neptune, the next farthest planet is Uranus. With a distance of approximately 1.784 billion miles separating it from the Sun, Uranus will be placed near the 33-yard line. Like Neptune, Uranus is one of the 4 Jovian planets in our solar system. Despite being a little over a billion miles away from Neptune, the two actually share very similar qualities. Despite being significantly closer to the Sun, the surface temperature of Uranus is almost identical to that of Neptune's, consistently maintaining a temperature below negative 300 degrees Fahrenheit. Also similar to Neptune, Uranus is roughly 4 times bigger than the Earth and has a composition that consists primarily of water, ice, and various forms of gases. Due to the similarities in their relative size, we have also decided to represent Uranus with a bean. Next, we move on to the big boys, Saturn. Sitting at close to 890 million miles from the Sun, Saturn will be placed only 31 yards away. This gives a great representation of just how far Uranus and Neptune are away from the rest of the planets. Another interesting thing about Saturn is that unlike the other 3 Jovian planets, its rings appear bright and extensive. These rings are made up of ring particles that reflect close to 80% of the sunlight which falls on them. But, with that being said, things aren't getting too much warmer. With an average surface temperature of around negative 290 degrees Fahrenheit, it's no surprise that Saturn is considered a cold gas giant. However, despite being a giant, Saturn is actually the least dense of any of the planets in our solar system. With a composition that consists primarily of elemental hydrogen and helium, Saturn actually has an average density lower than that of water. This means that hypothetically, if we could place Saturn in a bathtub full of water, it would flow. This is impressive considering it's the second largest planet in our solar system. But despite being almost 10 times as large as the Earth, an accurate representation of Saturn's size relative to our scale would be that of a grape. Now, to the biggest of the known planets in our solar system, Jupiter. Jupiter is approximately 483.8 million miles away from the Sun, which would put it at the 17-yard line. Due to being surrounded by ring particles that are much less massive than those near Saturn, Jupiter's rings tend to be less apparent and weren't discovered until 1979 by the Voyager 1 spacecraft. As we progressively move closer to the Sun, we see that things are starting to get somewhat warmer. Now, it's strange to consider negative 230 degrees Fahrenheit as warmer, but it'll start making sense when we see how much farther these planets are from the Sun in comparison to the Earth. Like Saturn, Jupiter is composed of various forms of gases as well as molecular hydrogen gas that changes to a liquid at its base. Despite similar composition, however, Jupiter is by far more massive than Saturn and is the most massive of all the planets. Yet, due to it only being about 11 times larger than Earth, an accurate representation of Jupiter using our scale would, again, be a grape. Now, onto the terrestrial planets. The next farthest planet from the Sun is Mars. Being about 141.6 million miles away from the Sun, Mars will be placed at the 5-yard line. As we inch closer and closer to the Sun, it is finally time to start shedding those layers. Despite having extremely cold temperatures at the poles, Mars also experiences temperatures up to 70 degrees Fahrenheit at the equator during midday. With its iron-nickel composed core and its silicate mantle and crust, Mars is the farthest planet from the Sun that is composed primarily of solid material. Despite being the second smallest planet in our solar system, Mars is much more dense than any of the Jovian planets we have previously discussed. Being just on the edge of the habitable zone, a lot of research is being done to see if there was once life on Mars or if people could live there in the future. Evidence has been found to support the idea that liquid water once existed on the surface of the planet, but no matter how intriguing of a planet Mars may be, its size with respect to the Sun is quite insignificant. According to our scale, an acceptable representation for the size of Mars would be a grain of turf. Now we move on to our home sweet home, the Earth. The Earth, thankfully, is about 93 million miles away from the Sun, or, in our model, a little over 3 yards. I say thankfully because it is this distance that allows us to have sustainable life on Earth. With an average surface temperature of near 57 degrees Fahrenheit and a surface made up of a little over 70% of water, the Earth is fantastic for the sustaining of human life. The Earth is made up of an inner and outer core, with the inner core being solid iron and nickel, and the outer core being their liquid forms. The mantle and crust are then made up of various forms of rocks similar to Mars. This being said, the Earth is actually the most dense of any of the known planets in the solar system. But again, its size is extremely small with respect to the Sun. According to our scale, an accurate representation of the Earth would be a pea. Okay, things started to get really hot, really quickly. The next closest planet from the Sun, and also the hottest on average, is Venus. Despite being less than a yard away from the Earth, Venus's surface reaches extremely high temperatures. Due to its incredibly slow rotation rate, on average, the temperature of Venus is close to 860 degrees Fahrenheit. I'm not sure if that tank top will cut it, Jared. This heat is due to the thick atmosphere surrounding Venus, which creates an incredibly strong greenhouse effect. Because of this, the surface of Venus seems to consist primarily of volcanic activity and lava flows. Although it has been difficult to study, it is believed that Venus' interior is actually quite similar to that of Earth's. The two planets are quite similar in size, mass, and density despite the extreme disparities in surface temperature. With that being said, Venus will also be represented by a pea. Finally, we have reached the closest planet to the Sun. Placing it at about 1 yard away from the Sun and almost 99 yards away from Neptune, Mercury is only 36 million miles away. Although it is as about half the distance as Venus, due to Mercury having no atmosphere and slow rotations, its temperatures vary greatly. The side that is facing the Sun can reach up to 869 degrees Fahrenheit, while the side facing away from the Sun can drop to as low as negative 300 degrees Fahrenheit. Mercury is composed of a large iron-rich core and a rocky outer layer. It is by far the smallest and least of all the planets, but also has the second highest density. As we did with Mars, Mercury will be represented by a grain of turf. This is our solar system. It's more vast and intricate than we could possibly imagine. What is even more fascinating is that even with all the information that we have collected so far, we haven't even scratched the surface with regards to understanding all that there is to know about the worlds that surround us. We hope that this presentation has provided you with some insightful information and encourages you to go out and to try and learn more about what takes place outside of our little pea of a planet. Thank you.